In this question, we are given a source which is having voltage V and two identical capacitors, each having capacitance C with air core is connected like this. Initially, the switch is closed. When the switch is closed, both capacitance will be charged to this potential V. We have to compare the energy, total energy stored in the two capacitors when the switch is closed. Then what we do after that? We keep the switch open, introduce the dielectric in the two capacitors. When you introduce the dielectric in the two capacitors, the capacitance will become K times C. In this case, K equal to 3. So we can take C1 dash equal to C2 dash equal to 3C. That is after introducing the dielectric. You notice here when the switch is open, C1 is still connected to the battery, whereas C2 is disconnected from the battery. That is the key point in the problem. Okay, so total initial energy, let us calculate that first. It is half CV square plus half CV square equal to CV square. This is the total energy. Now, after the switch is open, what is C1 dash? C1 dash is 3C. Therefore, energy of C1 after opening the switch is equal to half 3C V square, which is half CV square into 3. We can write like this. Now, this is for C1. What is for C2? For C2, it is no more in connection with the supply voltage, but it has been charged, it has have a charge Q. So, energy on C2 after opening the switch is equal to half Q square by C dash. Now you must write C2 dash because the capacitance has changed. What is Q? Q is equal to CV. Q equal to CV and C2 dash is equal to 3C. So substitute that here. So we have energy on C2 is equal to half C square V square by 3C. So half CV square 1 by 3. Add these two. So total energy after opening the switch or final total energy is equal to half CV square 3 plus 1 by 3 equal to 10 by 6 CV square. So what is the ratio we want? We want the ratio of the initial total energy by final total energy. What is the initial total energy we calculated as CV square? Final is 10 by 6 CV square. So CV square divided by 10 by 6 CV square equal to 6 by 10 or 3 by 5. Option number 3.